Go, Dylan. Faster. Oh, the numbers are so big.
Why did you make it so hard?
Challenge your students.
Oh, now you might beat me. I can't multiply.
I can't multiply either. Don't worry about me. You liar. What's 3 minus 6?
Yeah, probably.
Why does Steve? Wow, I am way off.
All right. So what I just did is called synthetic division. Okay? So somebody took the process of division and compiled an algorithm, a series of just kind of arithmetic steps that you can do to kind of duplicate the division process without actually doing the entire division process. Okay? Parameters. Polynomial divided by a polynomial like we had here. Okay? So we had 10x to the fourth minus 2x squared plus x plus 20. And that was being divided by x minus 7. Okay? So first thing, this only works when you're dividing by binomials of the degree 1. Okay? So if I wanted to divide by x squared plus 3x plus 2, is this going to work? No. Okay? But a lot of the time, we're dividing by binomials with degree 1. Because if we know a factor, it's usually a binomial of degree 1, right? If you want to divide it out and see what's left, there's oftentimes you're dividing by that. So even though it's only useful in one situation, the situation it's used in actually makes it extremely useful. Okay? Do I get to completely forget long division? No, because this only works for this scenario. So if you're asked another division problem, you still have to be able to complete that. Okay? So we got to keep those skills. So it only works dividing by binomial degree 1. So what did I do? So here was my setup to the problem, was this line right here. Okay? So does anybody think they know where I got this information from right here? Dylan.
It's the 10x4 and then the x cubed. It's the coefficient.
Good. It's the coefficients. So it's the coefficients of the terms of the polynomial I was dividing. Where is the 0 coming in from? Austin? Good. There was no x to the third. We talked yesterday about having a placeholder. This was the placeholder that should go between those spots. This won't work if you forget the placeholder, because as you saw when we did long division, each time we multiplied by a power of x, it only went down 1. So if we try to skip one of those steps, we'll have the wrong numbers lined up with each other. They wouldn't be like terms. Okay? All right, where did this number come from over here? Yeah, Maya. Good. Okay, so if x minus 7 is a factor, then 7 is normally the 0 of that factor, right? The thing you get when you set it equal to 0. So when you do a division problem, there's the dividend, the thing that's being divided, and there's the divisor, the thing that's doing the dividing. The number that goes in this box is always the 0 of the divisor. Basically, the x value that makes this guy equal to 0. Are we good with that? Okay, now, what the heck did I do with the numbers? So I put this line here. Got a little messy because the numbers got big, which is fine. Whatever. Okay? So what's the first thing I did with the first number? 10. I moved it down. Okay. Then in the next column, the 0 already existed. Where did the number 70 come from? 7 times 10. So basically, anything that ends up down here, guess what happens to it? Gets multiplied by this 0 of the divisor and fills in the empty spot in the next column. Then what am I doing with the column? Okay, it looks like I put it down, so let's see if that pattern continues. I put it down, I put it down. So then I have 70 down here, okay? When a number shows up down here, what do I do with it? Multiply it times 7. Okay? So that would be 490. But did I just put 490 down here? No. What happened? It combined it. So that actually happened here too. So basically, every time you fill up a column, the terms are getting, or the coefficients are getting added together. Maya? Oh, it should be 488. Dang it, so I got it wrong, people. Oh. Defeating. Did you finish, Jarrett?
I finished.
Oh, then you win. Maybe I have a prize for you, or maybe not.
I don't know. I might have gotten it completely wrong. It might have gotten. I don't know. I was doing pretty bad. It was pretty bad.
Yeah, no, you didn't get this right.
Yeah, I did not. I was so.
You didn't get it right?
You just let everyone down.
I haven't exactly looked at it.
I did.
You failed us all. Please, Jared.
Okay, I'll change my last number in a minute. All right, so, thanks, Maya. All right, so then we add these up. So columns get added. Are we good with that? Okay. So then what happens when I get 488 down here? I multiplied it by 7, okay? That gives me this. I add up the column again, and I get this. Okay, when I get a number down here, I multiply it by 7. Hold on a minute. Now I have to fix this. 9, 10, 11, 28, 29, 21, 22, 23. Okay. Then I put the number here. I add up the column. I get this here. Now, how did I write my answer? Let me adjust my mistakes a little bit. Yeah, it just needs to do that. 2, 3, 9, 39. Okay. So this is the synthetic division process, but this is not the answer to anything. Okay? What this is some work I do on the side of my paper, set up in a quicker fashion than long division for this type of scenario. But I have to be able to set up this work, and then I have to be able to read the work. What is this telling me? So I went from this, and I write this answer. What are we saying? How am I getting the answer? Damien?
I have a question.
Yep.
When I was doing long division, it was 10x cubed plus 7x. I don't know how you get the 7 used without the long division.
Did you put a 0 placeholder in?
Yeah.
Then if you put 10x and they multiplied together and you got 70 in the next spot, it should have been 70 when you added it up. Okay. Yeah.
Why is it like 10x cubed?
Okay. So let's talk about the numbers first. Where are the numbers in my answer coming from? This, right? Okay. The last number is the same thing that the last number you get in your long division. You stop the long division after you've done, you have all this stuff here. You've done all this work down here. You've dropped the last number, finished something, and then down at the bottom you get your remainder, right? That's what this last number is here. So notice that it ended up right here over x minus 7 because it was the remainder. The same thing that you would have done if you had long division, right? What comes before the remainder in your long division answer is the constant, right? So this number is always going to be the remainder. The one before that would be the constant, the term that has no degree, no power with x. What's going to come before that with the way our polynomial building works? X to the first power, and the term before that would be, so this is one way to look at it. The ending always has to be a remainder, and that's how it would work back. The other way to look about it is just think about it logically with math. You were taking something that was to the 4th degree, and you were dividing it by something that was to the 1st degree. Think about maybe the simplest form of that kind of division problem. Something to the 4th degree divided by something to the 1st degree, the answer would be to the 3rd degree because one of these degrees is going to get canceled out with this. remember, your answer has to be, what would I multiply by this divisor to get this polynomial back? So if this has an x in it, my answer can't have an x to the fourth in it, because if I took that x to the fourth and multiplied it back by that x, I would get x to the fifth, and that's more than what I have here. So my answer should always be 1 degree less than the one I started with if I'm dividing by something with first degree, which is all I'll be doing with synthetic division. Okay? All right, so let's practice this a little bit. Our numbers won't get as big this time, I promise. Sorry. You're fine, Stephanie. All right, so we're going to try these two problems. I know, and I reformat it every time and save it, and it just doesn't. Okay. Yep. All right, so somebody give me the setup for part A. I'm going to do this division problem. Do I have synthetic division as an option? Yes. Okay, because I'm dividing by a binomial with degree 1. Okay. So setup. What goes in my little box? 3. Somebody tell me how they decided that. Elijah. Good. Okay, this is the 0 of the binomial we're dividing by, or the 0 of the divisor. Somebody give me the line of numbers that I'm going to line up after that 3. Damien. Good. Okay. Why didn't I have to put in any zeros? Somebody raise your hand and tell us. Yes, Sophia. Good. There's no need for a placeholder. This polynomial started with 3, then went to degree 2, degree 1, constant. Looks perfect. Got it? All right. What's the first step in the synthetic division process? Move the 6 down. Good. Then what do I do? Multiply, right? So 3 times 6 is 18. That fills the next column. And what do I do when a column's full? Add it up. Okay. Now 3 times negative 1. The column's full, so I add it up. Okay. Next thing I do, 3 times negative 2 is negative 6. The column's full. I add it up. Okay. So what's my remainder? 0. Ooh, what does that tell me? This is a factor. Good. That x minus 3 isn't just dividing this polynomial. X minus 3 is an exact factor of this polynomial because it went in evenly, right? All right. Negative 2. What part of my answer is that going to be? Constant. Negative 1 with x, the linear term, and 6 with x squared, the quadratic term. So somebody raise your hand and tell me how I write my final answer to this division problem. Damien.
6x squared minus x minus 2.
Good. I don't need to write the remainder because it's 0. Dylan? If they asked us to factor it further. But here all they asked us to do was divide that polynomial by that one. So what Dylan brings up is what we're going to see later in the lesson, which is really important to us. We have to pay attention to directions. If the question was, is x minus 3 a factor? This work answers that question, and I would look at the remainder. If they asked me for the remainder, I would look there. But here they were asking for what is the answer when you divide the problem? That's this. So this work is actually going to be a simple set of work that we can do for a lot of different things. But we got to know how it works to be able to answer the question that they're asking. Okay, the work doesn't answer the question. We have to be able to interpret it properly. Okay? All right. So B is a little bit tricky. I'm going to help you guys with setup, and then I'm going to let you guys finish it to make sure you can do the process. What do you think is going to make part B a little bit tricky?
The number that's going to be in the box at the top is not going to be integer.
Okay, so first of all, we're going to have to deal with fractions. All right? Now, that makes things a little bit tricky. I want to give you a little bit different perspective of this problem just for a minute. So here's what the problem is saying, just written a different way. It's asking us to take this and divide it by this. Okay. The synthetic division process kind of like the completing the square process. Like people came up with these procedures for you, but they only work under certain parameters. Okay? Only works when you had a binomial with degree 1. And really, to see the outcome, we need it like our problem that we did. We need to have a lead coefficient of 1 here. Okay? That's possible. If we think of factoring a 2 out of this, it would look like x minus 1/2. Okay? But then think about, like, okay, let's say I wanted to do 12 divided by 18. Okay, if I wanted to do that division problem. I would probably reduce this first, right, before I would attempt the division. 12 and 18 both have a factor of what? 6. So I might think of 12 as 6 times 2 and 18 as 6 times 3, which means if I can take the 6 out of both of them, instead of having to do 12 divided by 18, I can really just do 2 divided by 3 and get the same answer. Is that okay with everybody, that idea? So if I don't want this 2 here, that's all fine and dandy, but I need another factor of 2 up here so that I can then do the division with x minus 1/2. Does that make sense? Okay? Like you can't just take a factor out of one of them and not out of the other. So whenever you have a coefficient here, you're kind of forced to do this, and then you need to do the same operation here. Okay? So when I factor a 2 out of the numerator, what's the first term going to be now? So we have 2x to the 4th. Then we're going to have 5 over 2x squared. Don't freak out. We're going to have some fractions. We're going to have to deal with them. Here we're going to have x, and here we're going to have 2. Is that okay with everybody? So Zeke is right. Our number in the box is going to be 1/2 because we're really kind of thinking about dividing by x minus 1/2. So the number that I could plug in for x that makes this equal to 0 is 1/2. But because it had that coefficient, I don't want to plug 1/2 into the synthetic division process with the original coefficients. I want to plug it in now that all the other coefficients have been divided by 2 as well. I want to be consistent with my numerator and my denominator. So now I'm going to use coefficients of 2. It's missing an x to the 3rd, so I would put a 0 placeholder there. Negative 5 over 2. 1. And then 2. So I'm going to go ahead and do the synthetic division process with this setup. Okay? All right, so go ahead and finish the division process, and we'll check our answers to make sure you guys... Okay, you guys can double check my arithmetic, because as you saw in the previous demonstration, sometimes with multiplication, addition, and subtraction, I'm not so great. But I think it looks pretty good. So I would originally write my answer like this. The reason I would write my answer like this is this factor of 2 is like gone. So I was really dividing this polynomial by x minus 1/2, and I get this solution. Now, it's going to bug you a little bit. After all that work, they don't like the fact that this has a fraction within a fraction. So you usually have to do a little bit to fix the remainder if it has that fraction in the denominator. So a little bit bothersome, but basically multiplying this denominator by 2 would get rid of that fraction, and then you just have to do the same thing in the numerator. I'm not multiplying the whole thing by 2, okay, because this is one piece of it that's a fraction. This fraction is equivalent if I multiply both numerator and denominator by 2. So that's just going to change the remainder part to say plus 4 over 2x minus 1 instead of 2 over x minus 1/2. That's considered the proper way to write it so that there's no fractions within the fraction remaining. Yes? Because that was in the original problem. It doesn't always work out to be what was in the original problem depending on how the numbers work. Some of you might have taken the original problem and done 1/2 and then saw a pattern of like everything is half. There are some other patterns that exist. This is kind of the more traditional way that will work every single time. If you find a different way, that's fine as long as it's consistent and works every single time.
Oh, yeah. My question was going to be, on like the test, are you going to ask it to do synthetic division or if you just do the
You can do both, but we're going to see why synthetic would be useful in a minute. How we would use it to do some things like factoring, things that we might not have been able to factor by hand previously. Okay? All right, so any questions about the process of synthetic division? So there's long division, there's synthetic division, there's uses for both. I can't completely get rid of long division. What if I'm not dividing by something like 2x minus 1 or x minus 3? If it had an x squared or something, I have to use long division. Okay? Synthetic division is much faster, okay? But obviously, like someone said, do I have to do this? Well, we're going to see how it's useful, and you'll see if you like that. Yeah. Yeah, so that's what they said. Could you do long division? If I just ask you to divide, I don't care. So we're going to see some reasons why synthetic division might be useful. Okay? All right. So sometimes this synthetic division idea is also called synthetic substitution. Okay? So here's what I want you guys to do. There's a polynomial up here. F of x equals 2x to the fourth plus x to the third minus 3x squared minus 5. First thing I want you to do, just find f of 2. Go ahead and plug in f of 2. Just like you would old school, I'm asking you to plug in 2 for x. What is f of 2? Okay? So don't mind me, I'm doing something different. All you are doing is calculating what is f of 2. Does everybody understand that? We're just doing part A with that polynomial. So while you guys are doing that, what I did is I just set up what synthetic division with this polynomial would look like if 2 was the number in the little box. Okay? All right, so what did you guys get for f of 2? 23. Okay? Everybody in agreement with that? We take 2, we plug it in for x, we do order of operations or whatever, and we get 23 at the end. Everybody's good? Look at my synthetic substitution or synthetic division process. Notice the spot that we called the remainder is 23. So that's not coincidence, okay? It turns out this process can be used the same as substitution or for division. A little confusing, okay? But what it means is if 2 is the number right here, the remainder is the number I get when I plug 2 into the equation. But it also tells me if I'm taking the equation and dividing it by x minus 2, right, where 2 would be a 0, this whole thing is the polynomial that I'll get as an answer. So I want you guys to use the work that I put right there, the synthetic division work with 2. We kind of saw a relationship, a new relationship that we didn't see before about this. See if you can answer these questions. Okay? So the work is right there. That work can answer all of these questions. So see if you guys can do that right now. Okay. Answers to this. So can somebody raise their hand and tell me what is f of x divided by x minus 2? Damien.
2x cubed plus 5x squared plus 7x equals 14. Remainder 23 over x minus 2.
Perfect. Okay? Same work. Didn't have to do any new work, but this is the answer to the division problem, right? If this number in here is the 0 to this, then this tells me the coefficients of the polynomial that's the answer to the division problem. So the remainder can tell me what I get when I plug this into this function. The whole line of coefficients can build for me the polynomial that's the answer when this function is divided by x minus this number. Okay? All right. The remainder when f of x is divided by x minus 2 is what? 23, right? We already marked it. Is x minus 2 a factor of f of x? No. How do I know that? Because there is a remainder, right? Is 2 a 0 of f of x? No. Because in order for 2 to be a 0 of f of x, a couple things would have to happen. One, if I plug in 2 for x, what should I get for y? 0. Not what I got. Okay? Second thing, if 2 is a 0 of f of x, then x minus 2 is a factor of f of x, and you already answered no to that question. Okay? Is 2 a solution of f of x? No. Question F is no different than question E because solution is a word that is synonymous with 0. Okay. So this little piece of work can find all these different things for you. That's kind of the idea. Okay. All right, so here is another one. Go ahead and take that function, divide by x plus 2, and answer these questions. Find f of negative 2. Is negative 2 a solution? Is x plus 2 a factor? What is f of x divided by x plus 2? Rewrite f of x in factored form. Can you find the other zeros besides negative 2? And try to sketch the function using the zeros. So this is going to... Okay, so here's my work. It's synthetic division work, but if I can't read any of it, it doesn't help me. So that's why we're asking these questions over and over again. Okay, so first question, part A. A little hard for me to reach, so I'll just write it right here. Okay. What is f of negative 2? 0. Okay, 2 ways for me to know. Old school way, go plug in negative 2 for x and figure it out. Other way, right here, I can see that when the number negative 2 is plugged into this function, the result is 0. Okay? Question B, not P. We don't go from A to P. Okay. Question B, is negative 2 a solution of f of x? Yes, because solution means the same thing as 0. We just said f of negative 2 is 0. So this time the answer to that question is yes. Is x plus 2 a factor? Yes, because the 0 of that is negative 2, which means the work would be the same. It went in evenly. Then it is a factor. Okay? What is f of x divided by x plus 2? Somebody raise your hand and give me the polynomial. Anna. Oh, you weren't raising your hand. I see Austin and Damien and Zeke raising it. Yes, Kyle. Good. X squared minus 3x minus 4. And we're getting that right here, right? Constant x squared. Okay, so let's rewrite f of x in factored form. Somebody give me one factor that you know exists for f of x. Okay, good. The one we divided into it, x plus 2. If that's one factor, what is the other factor? CJ? Okay, so he says, right, x minus 4 and x plus 1. Now, he didn't just work magic and know that. Where is he getting those factors from? Jarrett? It's like when you say that 6 divided by 3 is 2, right? 6 divided by 3 is 2. That means you know that 2 times 3 makes 6, right? So if I say that f of x divided by x plus 2 is this answer, then this times the thing I was dividing by would give me back the polynomial. So when this goes in evenly, I know that's a factor. I know the other factor is what I got from the division problem, and if I can factor that further, I do. Okay? So what are the other zeros of f of x besides negative 2, because we already established that up there? Sarai?
4 and -1.
Good. 4 and -1. All right, let's try to sketch the function using the zeros. Okay? How many distinct zeros do I have? 3. So one of them's at 4, one of them's at -1, and one of them's at -2. What degree is the function f of x? 3, which means it's a cubic. What does that tell you about its end behavior? CJ?
It goes up, makes this that.
Okay, so he says it goes like this. You guys good with that? And because it has a positive lead coefficient, it stays this orientation. It doesn't flip around the other way. Okay? So basically, I just have to draw this shape and make sure it goes through these, right? So I want to end this way over here. I want to end this way over here. Did I say I'm going to care that your middle points are in the right place, your relative maximums and minimums? No, I'm okay if you have the right shape with the right end behavior going through the zeros. Okay? It's a little review of how all this relates together. Okay? All right. So your groups are going to do this together to finish. Let me just make sure. Actually, let's do this first, and then we'll have you guys do the other part at the end. Okay, so here's a polynomial. This polynomial is supposed to express the volume in cubic inches of a box. If you know the length of the box is x plus 5 inches, what are the other two dimensions of the box? Talking, so share with us if you have something to say. So ideas. Is there someone that hasn't talked to me at all today that has a starting point or an idea for us? All right, Stephanie, I guess you can start. You just put up our problem. You didn't give us any answers to anything. So, okay. So what was your idea?
First do the synthetic division.
Okay. With what did you put in the box?
I put
Okay. And what did you use as the coefficients?
1, 9, 20.
So somebody tell me what her rationale is for doing this. What is she doing by doing this? Damien?
Last number would be 0.
Okay, so first she's trying to say, like, well, it says that x plus 5 is one of the dimensions. Is it a factor of this? Can I factor it out and try and get closer to the other dimension? So let's check and see. Okay, so x plus 5 divides evenly into that. I would expect that because literally if this is a box and I got its volume, meaning I multiplied 3 of the things together to get this answer. So let's say I multiplied like 2, 3, and 5 together, right? And then I would get 30. 2, 3, or 5 should all go evenly into 30 because they were one of the multiples to make it. So this should have happened. If this didn't happen, you would have a hint that you either set something up wrong or went through a process wrong, because when they tell you one of the dimensions is x plus 5, it was in the multiplication, so it should be a factor. Okay? So that means you know that x plus 5 was multiplied with x squared plus 4x plus 3 to make the volume. Is that fair to everybody? Is that okay? How many other dimensions am I looking for, though? 2 other dimensions to make volume. So this is the one they gave me. This needs to be broken up further into 2 dimensions. Elijah? Good, but I think I'm going to argue with you that they should be pluses. Okay. So we would just factor the quadratic how we already know how to factor, and then we have 3 dimensions, right? Like a length, a width, and a height that would all multiply together to contribute to the volume. Does that make sense to everybody? So these would be our dimensions of our box. Okay, so what's going to happen a lot with these division problems is I might give you one of the factors and then ask you to find the others, because if it's like a cubic, okay, if you can get it down to a quadratic, then you should be able to use all the other methods of things that we know to find zeros or factors. Make sense to everybody? All right, so your last 2 minutes. Think about these questions, okay? What is a zero of a function, graphically or algebraically? How is a zero of a function related to a factor of the function? And how do you determine the maximum number of complex solutions that a polynomial function can have? Actually, let's talk about this for a minute just together, because we only have 2 minutes and we didn't really discuss this. It's in the note guide, but you don't have to. It's fine. It's just like things that we should be able to explain, right? Because we're often asked to explain. So the maximum number of complex solutions. So let's say you have a cubic. What's the maximum number of solutions, period, the cubic can have? 3. Complex solutions, do they ever come alone? No, they always come in like those conjugate pairs, okay? So how would you figure out what the maximum number of complex solutions of something is?
Take the number of solutions that is available, divide by 2.
Okay, so he says take the number of solutions available and divide it by 2. Is it always going to split up evenly in half, like half of them real and half of them complex? No, right? So let's say I had a cubic and I found one real solution. How many complex solutions are there? Probably 2. Okay, and that makes sense because they come in pairs, right? Let's say I had a quartic, okay, and I found 2 real solutions. Then there could be 2 complex solutions. So it would really depend on the number of real solutions of the polynomial and the degree of the polynomial. Is that okay with everybody? All right. What is a zero of a function? Real quick, who can tell us? Okay, I hear a solution. A number that when you plug in y equals 0. Did they take yours? David? Okay. Sarai? Good, where the graph crosses the x-axis. All these things are now connected in our head as understanding as being parts of zeros or solutions, right? How is a zero of a function related to a factor of the function? When you hear the word zero, how does that make any relationship with a factor of that same function? Zeke? Sorry, Elijah. Good. Okay, so if it's a factor, right, then the zero of the factor is the zero of the function or the solution, okay? All right.